Hello, everybody. So welcome to the Show Me Your REPL. This is 5th episode, and my pleasure to have Juan Monetta. And this is experienced Clojure developer, and he is author of flow-stor debugger. And so welcome, Juan.
Thank you for having me.
Yeah. So can you tell a little bit about you? And then I know that you have amazing stack. Everything is very interesting. So yeah, let's start.
Nice. So yeah, I mean, I have been programming since the late 90s, I think, and professionally think, late 90s, 2000. And I wrote programs in Java for a long time and C++, and then started using Common Lisp around 2004. Also discovered Emacs around that time. And then I was using Common Lisp for my hobby stuff and Java for work until I discovered Clojure around 2010, and have been working professionally since then, using Clojure in different kind of companies here in Uruguay or in the United States. And
How did you discover the Clojure? Was it some post or?
I mean, I remembered I was doing Common Lisp, and I was super interested in Lisp languages. And I think I saw Clojure in 2009, but it was related to the JVM, and I was doing Java, and I don't, I was kind of hating Java, so I didn't want to touch it. But then, I tried on around 2010, and it was amazing. And I got into functional programming and immutable data structures and all that stuff that I wasn't doing on Common Lisp.
Awesome.
And it was nice. I mean, it was amazing that it was on the JVM, because I could start immediately using it at the company I was working, that we were doing a lot of Java stuff. So I could start writing small projects and show it to people.
So it was you who introduced Clojure in this company?
Yeah, exactly.
Okay, awesome. Okay, let's share the screen and show us your setup. I know it's really amazing.
So I'll share entire desktop here. Let me see it here. Yeah. Can you see my screen?
Yes.
Okay. So yeah, this is I will talk a little bit maybe about the tools I normally use. So this is a very old laptop from 2013, ThinkPad, and I'm running Debian Linux. Have been using Linux since late 90s also. I like it a lot because you can customize it a lot. And so the basic tools I use for my Clojure work are Emacs. Then I use a terminal. In this case, for the terminal, I'm using just one terminal that I can bring with just a keystroke, and I'm multiplexing it with Tmax, which I find pretty convenient, because a lot of times I'm working with more than one project, or we are working with one project and some libraries, or running some Docker stuff or whatever. So I like this thing of having multiple terminals here and things that you can label also. So, and I find this pretty convenient. So yeah, this is an important part of my flow. Then I use Emacs, and also I am using the i3 window manager, which is it's not super important on my flow, but it's pretty handy because you can communicate with the Windows Manager from other processes. So you can do things like this. For example, you can send messages to the Windows Manager, grab these windows and move it to the right, or something like that. And this is pretty convenient for my development workflow. I will show some examples after. When you want your REPL to interact with your window manager, or Emacs to interact with your window manager, And yeah.
And this is another example of REPL, yes? So
yeah, exactly. Exactly, because it's running there and you can send messages without and interact with it without restarting. And I think that, I mean, my first encounter with a REPL kind of thing was Emacs itself. I mean, it's this thing that you start the process and you never restart it, and you just like modify it, enhance it, and do all the stuff without even like restart the process. And or you also debug it and everything. So I think it's pretty convenient. So yeah, those are my main tools. And then, of course, the browser and that stuff. But yeah, I think those are my tools.
So let's follow. How is your typical project looks like? So
okay, before that, maybe I can show you one thing that I have been using a lot lately, which is what I have called a clojure playground. So before this, I was like, when I wanted to try something, I was always creating very quickly a small project in temp to try some idea or something that I have just seen on Slack and I want to try it. So I created this clojure playground, which I think it has worked pretty well for me. It's a very simple dev.clj project that has only one dependency, which is the tool depth in this specific commit, which allows you to hot load libraries, hot load dependencies into your REPL. So what I do is I always have this REPL running and I never need to restart it. So if I want to try something, I will come. So I have a lot of namespaces here. For each idea, I create one namespace and I have a template. So if I want to try something, I will just copy this template into, I don't know, show me.clojure and open that file. And yeah, this is already has this line here I can modify. So I can hot load any libraries I want for this specific thing I want to try. For example, if I want to add hiccup, I will just evaluate this stuff and then I can yeah, use hiccup immediately. And I can do that with any library I want, which is pretty convenient to try things. And also you don't pollute like your temp folders with 1,000 projects, one for trying hiccup, the other one for trying whatever library, composure, whatever you're trying. So yeah, I have found this pretty convenient because if you also have your REPL running there in the background, you can try things immediately. I mean, not even need to start the REPL thing.
Yeah, great idea.
And yeah, and also while being here, because there are some, I can show you here some tools I normally use in this playground. It's so I have like some quick access to my dev tools, I would say. So I start every REPL with dev tools loaded. So I have on my main clojure dev.eden, so the dev.eden that is on your home, I have an alias there that called that dev tools, where I'm loading on every project for developing. I'm loading up a bunch of tools like for doing benchmarking and profiling and that stuff. And what I have also extended Emacs a little bit here, but you can do in whatever editor you like. It's having quick access to them, because so here if I hit one key, as you can see, it brings a menu at the bottom here, which some quick access to some dev tools I find myself constantly using. And I think this is, having this is pretty handy, because most of the time you want to use one of these tools, but you haven't been using it for a while and you don't remember the project name and the namespaces you need to load, what functions you need to call, and then you don't use them. And so how do you use them here? So if I don't know, let's say I have like a function that that I'm interested into, I don't know, decompiling into Java for some reason, so I can hit one key, F6 on my keyboard, and then I'm going to hit J, and yeah, immediately I can see the thing decompiled there. If I want to disassemble it, I can do exactly the same, but hitting the D for disassemble, and I will have the disassemble here. And also the same thing is if I'm just trying to figure out how long something it takes, I can just hit B for benchmark, and it should pretty quick run criterion bench on the quick bench of criterion on the form. So I think this is pretty convenient, and also, yeah, I found myself like if I have this quick access to all these tools, I tend to use them a lot more than if I have to remember like the dependencies and how I call them, and yeah.
And
so,
do you have these scripts available on GitHub somewhere? So
yeah,
can
so yeah, exactly. So I have a project called elisp-utils that it's on my GitHub, and so this elisp-utils has a lot of like for different things I work on, but there is for clojure here. And yeah, you can take a look at, for example, this is pretty standard stuff, and I find I'm fascinated in how easy it's to use emacs to interact with the REPL and all the stuff through cider. So I'm basically defining menus using hydras, which are some emacs thing, but then everything is just so this is calling, when you hit the key, is calling one of these functions, and this is basically just running the command cider interactive eval and sending whatever expression I want to send to the REPL. Most of it, I mean, all these commands are implemented the same way. It's pretty straightforward. You can take a look at my GitHub.
Yeah, that's
so nice. Yeah. So yeah, this is what I use normally to to try things. So I don't end up creating. Because of that, I almost never create new project unless I'm starting something that probably takes like a month or whatever. In that case, I will create a new project, and when I do, I tend to just start from scratch. I mean, create my deps hidden from scratch, don't use any template or anything, because then I can, because I'm not creating constantly new projects, I have a chance to review what is the current best way of doing things, like what test runner I will try, what kind of aliases I will put there, whatever. So yeah, I tend to do that from scratch when I need to. But yeah, that is for the playground thing. And going back to your question, I mean, like my standard project, let me jump to a small project I created here just for a demo. But yeah, I will go over the project. But my standard project these days are just deps hidden projects, and I use the clojure CLI quite a lot. I use it Leiningen a lot, but and it's amazing. But currently, I like the deps hidden a little better because it's just simpler for me. It's just like calling functions and nothing, like not plugging things or anything. So it's much easier for me if I want to debug something, whatever I'm trying to generate an Uber shard or something, and something isn't working. For me, it's just coming here and trying to figure out what function it's calling and go there and try to debug the code. And yeah, so it's not less magic, I would say. Yeah. So yeah, here I have a pretty small application. what I do in every application, it's like the beginning of the day or something. I will just check in a REPL. I don't start it from a terminal or anything like that. I just started here from emacs, and then I always have. Let me show you here. I always have like the source directory and also at the dev source, where I always put dev.clj. And so when I start, I will do that like jack in and immediately evaluate the dev namespace, which will load everything. Because dev namespace, it's also like requiring the application namespaces and everything but tests, but it's going to require everything. And right after that, what I do, it's like run this other thing I can show you. So I just show you like this thing. I have like this menu, which is like general Clojure tools menu. I also create dev menu per application. So in this case, if I just hit the another key, in my case it's F5, it will bring up like my dev menu for this specific application. It's going to be different for each project because it depends on what you need to do with the project. In this case, it's going to give me one key for refresh, which this is going to be a tool namespace refresh, so I can manage the REPL state. If I think it's going out of sync or whatever, I can refresh. In this case, I also have start system and stop system for. I'm not using any system library here, not Sierra components or mounts or anything, but just some custom thing. But it's that concept of being able to stop everything. In this case, the application contains a web server, so probably I want to stop the server and then start it again and all that stuff. And you also have, in this case, some other utilities. This small application uses a cache, and I want to have a quick key for clearing it, because when I'm trying something on my dev flow, sometimes you want to clear the cache, and that's a convenient thing. I think a lot of people, and I used to do it that way, create all these functions on the dev namespace for doing all this stuff, and then they probably like call it like this. I used to call it like this. But now I find it like if I'm with these dev menus, it's much faster, and it doesn't matter if I'm on a different file or I don't even have this thing open here. I just hit the key and can do that stuff. So yeah.
Where do you put all these elisp project-specific functions? In the same?
Okay. Yeah, exactly. So currently I have them here. So I have created this other small macro that I find pretty convenient also. That I call it like cider project hydra or whatever. Let me show you the one for this project, which is basically you can create a menu with a description, then you list your keys. You can give it command names if you want to call them in Emacs by command name. And then you have at the end, after the description of the action itself, you have REPL expressions. So it's pretty easy to, if I start a new project, I will copy one of these and just create bindings for my REPL expressions here. So I can do whatever I need. Just send this stuff to the REPL.
And in which file do you put this L project? I've seen something like, so you put this code into the root of the project, yes? As how it's loaded.
Yeah, exactly. Currently, I'm just loading this. So this is inside a Clojure Emacs list utility file, and I'm currently loading it when I start Emacs. So it's loading all this stuff. Well, the thing that is making the trick here is like I have a dir-locals thing where I do two things. One, it's telling Cider what aliases I want for this project. So in this case are my dev tools, dev test, and my debugger. And then what dev menu it should be using when I hit my F5 key in my case. So every project we have a dev menu name there. So this is how I link from a project into the menu.
Mm-hmm.
Yeah, I don't know. I should probably bring these menus also into the project source code tree so I can share them. I don't know. But currently I have them in one file in a clojure. Yeah.
Yeah. If you dump it in a gist and send us the gist, that would be nice. I will share.
Sure. Sure. And also all this stuff, I mean, it's everything on my GitHub. So, but I'll send the thing. So yeah, so right after this, so what I do is just hit F5 here and the S for starting the system. So yeah, it's loading the dev namespace, starting the system, and now I'm ready to start working on the application.
Mm-hmm. And a small question: are you a VI Evil guy, or you are using Emacs?
No, I used to use VI and around like year 2000 and before starting Emacs, and then I just used it like vanilla Emacs with Samsung.
Okay.
Yeah, without any, I mean, with my own customizations, I don't use like preload or whatever. Yeah. So yeah, I can show you before maybe trying something else. Like, what is this very quick tour of what this web application is about? So I can show you how I work with it. So yeah, this is a pretty standard. Let me run this here. Pretty standard web application. Which is it has one HTTP server running, which has one route. In this case, it's like the application is around weather alerts. So there is one endpoint there. If you hit alerts, it's going to just handle that route by it will hit Open Weather API for a weather forecast, and then it will like try to generate alerts if the temperature range is out of the provided range. So it's pretty straightforward. You give it a lat and a long, in this case for Uruguay, and then a temperature range, and it will just hit the endpoint and then post-process with some closure to try to generate, and then render some HTML back. As you can see here, using Hika. So it can render the alert, the weather alerts with, yeah. So pretty straightforward application. So, and now I have showed that the next thing I do when as soon as I start the REPL is I also start flow-stor. Because I do it like this, so I will hit my key binding for starting flow-stor, so I don't need to require anything. There is an emacs mode for flow-stor, and I will show you. So the emacs mode for flow-stor can do some things like instrument, namespaces, instrument, start, stop the debugger, and that stuff. So currently in flow-stor, if you have these modes, you don't need to write anything, require anything. You just hit one key and it starts. And the next thing I do, it's I have an integration here. This is how I use my Windows Manager, because I have I send I configure the i3 Windows Manager so I can bring front and back the debugger with one keystroke. Okay, the same thing I do with my terminal. It's another key. So I'm not constantly like instantiating the debugger and closing the debugger and all that stuff. So when I need it, I have it one keystroke away. So that's another thing I use i3 for. It's probably possible to do in other Windows Manager, but yeah, I'm using this thing.
Mm-hmm. And can you introduce the flow-stor? What is this? What is a flow-stor?
Yeah, sure. So flow-stor started as a debugger, so a way of being able to step over code. It's an IDE-independent debugger, so it doesn't matter what editor you use or anything like that. But it has been moving into a kind of a companion for your REPL or a sidecar. So it does debugging, but it does other things. Like I will show you, it can, for example, I mean, it will also provide a namespace browser where you can see all the namespaces that are on your JVM process loaded, and you can inspect like this clojure core, and you can see all the bars, and you can see the documentation there, and you can instrument stuff from here. It also has a way of handling tabs. This is like for people that use it like REPL, Reveal, or Portal, or that kind of tools. It's just that. So, I mean, if you tap something, in this case, I will tap like kind of a complicated value, like the one returned by all namespaces. If you tap that, you will have all the tabs here. So if I keep tapping different stuff, you will see them listed here. But now you can also like double click there and inspect them. So this is pretty convenient because if the value is kind of complicated, you can, with your mouse, start clicking. And as you can see here, we are navigating into the nested maps and collections structure. And we can move back and forth. We can see the types and things like that. But also it's pretty convenient because you can go from your REPL here into this inspector. But if while digging into your structures, you figure out that you are interested in this specific value, for example, this map here, you can hit the dev key here, give it a name. I will just call it B. Mm-hmm. And automatically you will have it here under user V. So now you can keep working from your REPL with that sub value there. So yeah, this is a pretty important thing on flow-stor, which is this companion, but it's not about like replacing the REPL. It's about like enhancing the flow with the REPL. So yeah, and it's also, it has a tap button here, so you can re-tap a value. This is because if you are, for example, using other tools like Portal, that they provide other kind of visualization tools that this doesn't provide, and you want to, you are using Inspector and you found this value is interesting to visualize in Portal, then you can click tap and it will send it basically to the tap system and it will end up into Portal or whatever you have. So it also like integrates with other toolings if you need something that flow-stor doesn't provide. So yeah, this is for tapping things, but it can also instrument things, so that then you have like the debugger part, so you can well, we can instrument this application. I mean, you can instrument whatever you want. You can instrument like a library. Doesn't matter if it's your source code, or you can instrument any library. So in this case, for example, I will instrument clojure set difference. So if I call here clojure set difference somehow, you will see the debugger is showing the code there, and you can single step over the code, like, okay, S1 was last 132, and then the count was 3, and yeah, you can single step over this and yeah, try to figure out how it works. And so this is the basic functionality of the debugger, which allows you to instrument any function and also uninstrument. So if I remove it from here and I clean the debugger state, so that the next time I call it, nothing would happen because now the function is not instrumented. But yeah, so how I use it, there are many ways of using it. So you can instrument a single function like we did there. But there's this other feature where you can instrument the entire code base. Mm-hmm. So for example, if I'm interested in trying to understand what happened when my project is going to handle this request, okay? So one thing we can do here, it's come to the browser here, filter the namespaces of weather. So this is our application. I can just select everything, and I can right click here and set instrument namespace full. So this is going to instrument everything there. You can see here they are instrumented. So yeah, so as you can see, there is already some stuff on the flow thing here because of macro expansion. So when you evaluate something, if the macros are I mean, some code is executing while it's macro spanning, but we are not interested in this, so we are going to clean the state. We have a keystroke for that. Yeah, so let's come here and run. I'll just hit refresh to run the application, and now we can let it finish. Okay, and now we have everything that happened for the request on the debugger. So we can do a couple of things here. One is single step everything. So, okay, this handler run, which call the cached handler alerts. This is the request, and here we are just stepping into functions, everything it's calling. But this is not, I mean, it's nice because you can single step into everything and see the values of everything, inspect them, and do everything. But it's not super convenient if we just executed a lot of things, because then you need to like click next like crazy. So next thing you can do, it's like the debugger allows you to jump around in time by using different perspectives of time. So here you can jump back and forth in time by clicking around or stepping. But you have this other tool here next to the code one. You have the tree view, and this is going to show you an expandable tree of everything that happened. So you can see the cached handler alerts, call it the location function, and then call it this anonymous function with call it handle alerts, and you can keep expanding this. And so this it's so times goes this way, and all these functions, if you click them, you can see the. Let's make this a little bigger. You can see the arguments vector here. So for example, this location got the request, so the ring request, the HTTP request, and it's returning the location from the query parameters there. So yeah, this is another way you can do to explore your code. It's going to print the values here using this level here, so it's not printing more than 5. But if you are interested in this value, you can always hit inspect, and yeah, then just start clicking around and things and all the stuff I showed before. But these tools also work together. So if you like by clicking here, you get into this, and you say, okay, this is interesting, this is not returning the value it should have returned, you can always like click here and do go to trace, and it will bring it here. So now you can single step and say, okay, this was the list, and now let me go over the keep. Yeah, you can check the conditions here. Okay, this is returning true, or whatever. So you can single step if you are interested. And yeah, so this is this tool that allows you to move through time in a different fashion.
This view is on function level. Yes, you see the arguments and the returned values, but you can
just function.
Yeah, you can get inside. Yes.
Well, I mean, functions. When I say function, you need to. It supports flow-stor supports everything. I mean, it's typed extension, multi-methods, function calls, all that that stuff. It doesn't need to be like a definite thing. So yeah, and there is also one more tool here, which is another way of looking at what happened, which is the function list here, which is going to show you all the functions that has been called, how many times they have been called. And then you can, for example, okay, make alert was called like 40 times. You can double click and see all the calls here. These are the argument vectors. Let me move this here. All the argument vectors. And yeah, if you're interested in this particular call, what happened there, you can double click here. And again, you can go to this piece of code and walk over this. So there are a bunch of ways of moving through time, through what happened. And I use this for a couple of different reasons. So it is a debugger. So when you are chasing a bug, but it's also a tool for trying to understand how something works. But by looking, not only looking at the code, as you can look at here, but looking at the values themselves, and the flow and everything.
Yeah, that's amazing. That's like introspection into runtime. So you kind of snapshot everything what's going on, so you can walk in time back and forth, see the values. Yeah, that's amazing. Yeah, you can touch the runtime with such tool.
Yeah, and it provides some other stuff, like for example, something I really use on web applications. For example, if you look at here, or let me grab something that handles the request. For example, let me go there. Here you can see the request, for example. So something I normally do is, like, instead of coming here and refreshing the browser, I will like capture the request once, and now define this. I will call this rec or whatever, and then I will go to emacs. Let me get rid of this, and so we have it here on the request. And now we can call the handlers by hand, because which is pretty convenient, because then you can call it there, and you don't need to go into the browser. And this is not shortcut, so there you have the return, which is HTML. And this is pretty convenient, not only because it's like faster and you don't need to go into the browser, but because you can use some other tools over this. For example, if I want to know how I'm expending my time on a specific handling a specific request, I can hit again my menu here, and I can hit the P now for profile this thing. Okay, and it will run, and it's already returned there. But now I can automatically see the profile of that. Okay, so how it's taking the time for the HTTP client, and yeah, I mean the here we have the handle alerts, and I can see like how much goes into the creating the alerts or retrieving the forecast or whatever. And that is, I think it's super convenient, because you are one keystroke away of understanding more of your request. And
yeah, for me, it's like you're in a matrix. So you stop at the time and you're walking in this frozen world, and you can do anything. You can change something. Yeah, that's amazing.
Yeah, exactly. And I think this is it's pretty interesting because it's I don't know if you can replicate this on other languages, because we can do this because of clojure immutable data structures, because we can just retain pointers to things, so the garbage collector doesn't collect them, and we can analyze every intermediate value. flow-stor also contains support for mutability, so if you're using mutable values like array list or something like that, it can snapshot them if you want and stuff like that. But 95% of the time, you don't need to do any of that because we work with immutable data structures. So yeah, it's a pretty interesting that that clojures allows. Clojures and this REPL workflow.
Can you tell a little bit more how this instrumentation works? So what the magic is done by Snow?
How does it work inside?
Yeah. So you're doing instrumentation. What's inside? Yeah.
Yeah. So it's basically, instrumentation is basically this, like it's maybe I can show you like this make more sense. I will do our trace here. Let me bring the debugger here. Let's just remove this. Okay. So the basic instrumentation here, it's so here I will basically wrap this expression with this tag, which means like instrument and run that form. Okay, so that is the basic thing you can do, and this is basically a reader macro thing. So imagine you are wrapping this into a trace macro, and what the macro will do, it's rewrite this piece of code. Basically, like if you do, it will do something like this. Like if you do, this is gonna be R for the result, and this is going to be another interesting thing. So this is going to be like I don't know, whatever, R. But now you are, it's like you are printing here. It's like you, let's say you also, like if you are tapping these things, okay? But instead of tapping, it's like, it's going to be like retain this pointer. Or something like that. So it's going to instrument the code. So the code will run and do exactly the same, but it will add code to basically, like if this retain this pointer will just store the reference in an atom or something like that. It's a little more involved, a little bit more involved now, but it's basically, this is the basic idea. So it's rewrite the code so it does exactly the same thing, but you retain all intermediate values.
But this is a reader macro, so it's not just a macro. So you could not macro expand your trace, or is it possible to macro expand?
Yeah, you can macro expand the traces. All this stuff is being done in a So here you basically can instrument your well, here basically the instrumentation system, it's a library that I developed there on GitHub now. That is the basis for flow-stor, and you can it's a function that you can provide a form, whatever form you want to instrument. It could be same function we did today. Okay, and here you need to put all the, I mean, it's going to instrument with some handlers you provide. So you can provide, for example, trace function call. Okay, And for tracing a function call, I want you to call the dev trace function call, whatever. Okay, like you provide callbacks. So it will instrument it. So when it runs, it's going to call these functions. And let me get rid of that. And here, yeah, let me, maybe we can print it like that. So if you look at the instrumentation here, because we only provided the trace function call, what it's expanding, it is expanded. The interesting part is this, the instrumented form. Like this. So this is what expand to. So it's this is the macro expanded of the macro expansion of the defend. So, but the only thing it has, it's here, it will do trace function call. So it's just retaining the vectors basically and tracing that it's if you do like here, like trace expression execution, for example, something. Now you see it's a little bit more complicated. So it's at the beginning of the function, it's tracing the function call, and then it's wrapping. It's saying, okay, let's trace the outer expression, which is going to be this, and trace this inner expression. So yeah, I mean, you just trace the value of B, of A, you then trace the value of the sum, and then you trace the outer thing as the return. I mean, but this is basically how instrumentation works. It's I have a talk where I go into a little more detail into how instrumentation works, but it's basically that. So this is not implemented currently into flow-stor because I splitted that part into this library. So you can, this is another library that I think it's pretty handy to try a lot of different tooling, because it allows you to instrument any forms and you give it your callbacks. You can give it a lot of callbacks here, for example, like trace bind. So everything that there is a binding on the arguments or on a let or something, your callback will be called. So you can you can then implement things like flow-stor by using this library. But the library is there; you can implement whatever you want. And also talking about that, this library, I implemented another thing that I also use on flow-stor. That is this docs thing I haven't shown you yet. So I used the library to basically instrument an entire code base, but instead of for capturing values and stepping over them, it is for deriving the types of the arguments of every function and return values and generate documentation for them. Okay. I will show you how you consume this documentation, and maybe if you want, I can show you how I generate the documentation. So let's go to any function. So the idea here is like when you have a function like this, for example, and you are like getting this is one problem you have in dynamically typed language. You have some argument called rec, and then if you need to work with that because I need to add something here on rec, then I don't know what rec is about. I mean, in this case, because we know that it's probably a ring request, we can go to ring documentation, or we can tap it here and try to print the thing. But then you need to also run it. So the idea here is that you can, when you need documentation, you can just click here, keystroke, for example, and it's going to automatically show the documentation on the browser here, on the flow-stor UI. So here now you can see that, okay, this is your handle alerts. These are your arguments. So request is a persistent array map. It can be a persistent array map. So because the language is dynamic, this cannot say, okay, this is never going to give you a comprehensive list of the things, because you can put whatever you want there. But it's going to see stuff that has been seen while running tests, which is mostly what you want. So here for the request, it's going to say, okay, it's a persistent array map, and it has these keys, and the URI is a string, and the request method is a keyword, so you know a little bit more, and it returns a string. And all this stuff you cannot figure out from looking at this. And you can do that with whatever functions. If you're interested into this get weather forecast, you click that, and now you have, okay, the arguments and the returns. And you also have call examples here. Okay. In this case, it's going to tell you, okay, for example, get weather forecast, when called with this, is returning this. So you have an idea of how to call the function, which is pretty convenient. And yeah, so consuming documentation, I think it's super handy, because if you have the documentation generated for your application or any library, you can then, if you're using Emacs, you can just click here and look at the documentation. If you're not using Emacs, you can see the functions here, all the functions that has been documented for this application. Yeah, you can click around. Now, what I will show you is what it takes for you to generate this documentation, because this needs to come from somewhere. Okay, so what I do, it's you can generate this documentation for any application with just one command, if everything goes well. So what I do in this case is I have a make-file here when I'm just running, so I don't need to remember this. I'm just executing the function inside the flow-doc alias while also loading the tests. Okay, and then what is this about? So, okay, the flow-docs alias, it's just something that says, okay, it will need an extra dependency of flow-stor debugger. So you need to bring that dependency. And it's going to execute this function, the cljoure, which is a function that is meant to be called for generating documentation for the command line from the command line interface. And then you need to configure the parameters of that, of how you want to generate the documentation. So there is a result name. So it's going to generate the documentation with some name. And the important thing here is this one. So for generating the documentation, you want to instrument these namespaces. So in this case is weather alerts, whatever. So everything under weather alerts, which are the namespace of the application. And then you need to provide a way of running the test or running something to exercise the code base. So after instrumenting that, you then have, okay, what should I execute? You can execute cognitive test runner API test with empty arguments of an empty map. The rest is just like configuration for like for the examples, like the print length, print level, if you want to pretty print them inside the documentation. So this is something you set up once, and then every time you want to generate the documentation, you just do like this. And it should call all this stuff. It's going to, as you're going to see, it's going to instrument the entire code base and then start running the test, which should run pretty quick because it's one integration test. This is just a slow startup. And yeah, there. So as you can see here, it's instrumented weather alerts weather and weather alerts HTTP server. it's telling you here it's instrumented every form but the first one, because the first form it's the namespace thing that doesn't do anything. And then it's running the test. And so this is and while it runs the test, it's reporting that it's sampling stuff. So at the end, it says it was able to sample 7 out of 11 functions that were instrumented. This is because the other functions are not being called by the test, because they are things like, as you can see here, like start server and stop server are things that the tests are not going to hit. So this is interesting because, I mean, you are running this because you want to generate documentation, but for free, you will also have kind of a coverage of your test. Not a coverage by expression, but at least a coverage by what functions are being hit. So if you want to improve your documentation, you can go and improve your tests. And yeah, and what all this process is generating is just a jar file. The jar file contains an hidden file inside, nothing more than that. So I'm putting it into a jar because it compresses the documentation quite a lot. But it's the hidden file inside documentation. It's pretty simple. So it's basically a map that goes from functions into another map that say, okay, these are the argument types and stuff like that, and examples and return types and all that stuff. So the ideas I'm currently exploring, it's like with these kind of jars, which are documentation, you can put into closures or something, so you can share the documentation. And then this documentation can be consumed from many different applications. So I'm consuming them from the flow-stor UI.
Yep.
But yeah, I mean, a web application can parse that stuff and generate documentations on the web, so you don't need to run the thing. How I'm using this here, it's just on dev.clj. On the dev alias, I'm loading that shard.
Okay.
So it's on the class path. And so consuming is just putting all your library documentation here on your class path. What flow-stor is going to do when it starts, it's going to merge all the samples hidden thing it found on the class path into the documentation map. That is why you then have all these things here. Okay. So if I add here like whatever documentation for data script or whatever it's on Clojure, when I start the REPL, it's going to get loaded here, and I will have access to the documentation.
Yeah, that's amazing. That looks like next level for source maps, yes, from JavaScript.
Yeah, I'm trying to experiment with all this stuff. Because I think there is a lot of room to experiment with deriving. If you want to go crazy, it's like your program executions as data. I mean, so like kind of trying to reify somehow the execution itself. And what can you do with the data that was generated by your execution? And yeah, I think you can do a lot of crazy stuff from that.
Yeah, that's...
And yeah, that is all I think for the current functionality of flow-stor. So you have a way of stepping, a way of browsing things, handling tabs, and doing documentation.
But that's pretty amazing. Any other brilliant ideas you want to put into the flow-stor?
There are, I mean, people like asking for on GitHub for like adding profiling stuff, like not super accurate profiling, but because you can instrument automatically every function, you can get an idea, a rough idea of how long it takes to execute everything. And I don't know for sure. I want to explore more things. I want to also try to extend this stuff so it works, because this stuff also, everything I have shown you, but the documents, all that stuff work with Clojure script also. So it's not for Clojure thing. It's yeah, and yeah, it can connect. I mean, it can do all this stuff by connecting to a shadow REPL, and so it can also like inspect the namespaces you have on the Clojure script and all that stuff.
Yeah, I see the huge potential for this. So this kind of the new point of view on your runtime, on your code.
Yeah.
This
I mean,
stuff is really amazing. Yeah.
And I have been using it. I mean, I have been working with it on and off for the past, I don't know, 3 years, but only the last year I just really put a lot of effort into it. And but I have been also, all these years I have been using it for different projects. I have worked for different companies, and I find it like super useful when I try to, especially if you want, also if you work on some complicated algorithmic stuff or something that you end up like putting print lines and all that stuff. I also use I used to use the cider debugger. I think this project even started in the beginning kind of a fork of a cider debugger, but then it went into a different direction because it's not a blocking debugger, it's kind of a tracing debugger. But I find the cider debugger amazing, and it's super convenient because you can use it I mean, here over the code. But what I don't like, it's like for complicated values, sometimes it's not super easy to see them, and also you can only step forward and cannot step backwards, and there's no way of like instrumenting entire code bases. You need to instrument like each of the forms, and yeah. But I think it's amazing, cider debugger, also because it's expression based. So. And yeah, this is for flow-stor. Then the other thing I find myself using quite a lot on my workflow, it's but I think a lot of people use it. It's like JVisualVM. So yeah, I use it quite a lot for the first for monitoring the heap and the garbage collection, just to have an eye on it. And from here, this I also do heap dumps and try to analyze heap dumps if I'm trying to figure out memory. And also, like, I use quite a lot thread dumps in case my application gets blocked or something, and I don't know why nothing is happening. So I can come here into the threads and try to figure out where each thread is stuck or waiting for what, or stuff like that. One thing I have been doing with this, it's just a tip, but I started using it recently. It's when I was using this, like when you have like 4 or 5 REPLs running, you never know which is which, because you come here and it's like, I don't know, is this the. So what I started doing, it's on all my dev.clj files. I always add this JVM JVM variable name, which is nothing, just a project name. So then you can see here. So if I look at this, I can see, okay, these are the weather alerts, and if I look at here, this is the playground. So because that was so I don't know if other people how other people.
Yeah, I personally struggled from this. Yes, this is a simple trick which is making it obvious.
Yeah, and you put it once on your project and then you forget. And there is also another thing, but that I started using recently, but I'm not an expert. or even close. It's the mission control, the JDK mission control, which kind of I want to share it because I think it's, I don't know how many people it's currently using. I think it's amazing. Why is this? Okay. And it's kind of overlaps with the JVisualVM, but it's also has a lot of so you can start the Java file recorder, which is something that can record a lot of things about your running process. And let me just record and then stop it, so we have something. And the difference is, like, I think, I mean, this part, it's like understanding your application, all these things, kind of what the JVisualVM provides, maybe with more details and things like file IO and socket IO and stuff like. But then it's also provide like JVM internals, and this, I think, you have a lot of details here that are not available on the JVisualVM. So I think that JVisualVM is easier to use, and it's just, I mean, I'm more used to it. But this is something that I think we Clojure programmers can learn to use. I still want to like learn a lot more about this tool, so we can also try to understand the environment we are on a little better. But I think, yeah, these tools, it's amazing, and yeah.
And can you tell us how you work with memory dump? So like some just few rules you're following when you're investigating what's wrong.
So that's a complicated thing, because the problem I found with debugging memory in Clojure, it's that when you do a heap dump, and you try to analyze the heap dump, the thing I find, the problem here is that if you expand whatever, like by number of instances, the thing is, like, everything tends to be like a persistent list or a persistent map or something like that. So everything gets mixed. If you are using records, for example, or def types, then it's nice because you see here, okay, I have a trillion users or a trillion whatever. But so yeah, that is kind of, I mean, you can try to figure out from here, for example, the persistent array maps, by looking and exploring. Yeah, this takes some time. And grabbing strings from here, you can try to figure out, okay, these maps are, okay, we have all these maps, and maybe you can figure out what the instances are about, but it's a nightmare. I mean, I would really love something that something like this, but that somehow you can differentiate. For example, if these things could integrate with for example, the Clojure meta, then we can probably like tint the objects. Like, for example, if you add a meta saying, okay, this is a user or something like that, then you can, I mean, maybe if this can be extended, how to look into meta of objects there or something. But I don't have a recipe. I don't know, maybe other people that know how to deal with memory and Clojure, but I have these problems.
Yeah, let's wait. Maybe somebody will put in a comment how to handle.
Yeah. And I have to, I mean, I have been using this quite a lot while developing flow-stor, because when you try to instrument a big code base, then you get a trillion, I mean, maps and everything, and you try to optimize performance there. because for example, for instrumenting clojure script and running all the clojure script tests, I have done that for running for creating the documentation for the clojure script compiler. And yeah, it takes like, I don't know, like 15 gigabytes of memory. And yeah, you need to deal with that stuff. But yeah.
Yes, interesting. But you still prefer to use maps over records and dev types.
Yeah, exactly.
And you were able to optimize without.
Yeah, the thing is, like, when you try to optimize with records or stuff like that, it's pretty tricky, because if you because the record also behaves as a map, but as soon as you add an extra key, it will automatically create a map next to the record. So now you have the type plus a map for the extra keys, and now you have two things. It gets tricky. So yeah.
But what was the main optimization things you did in flow-stor? Do you remember something which were eating your performance?
I remember a lot of like being wrong a lot. I mean, trying to rewrite something to use like records instead of map, or using just custom types or whatever. Or even try to like by playing with bits, trying to compress a lot of things into a long or whatever, and then measuring it and getting worse results. I mean, so it's for me, yeah, it's like everybody else says, it's all about like measuring and trying something. So I mean, and I don't think I'm really good at that, because it's the JVM is pretty tricky to optimize. I mean, it's because it's doing 1,000 things under the hood. So sometimes you try to improve something and you are just fighting against the optimization. So I mean, so yeah.
My last attempt when I was trying to optimize code was that finding that in my situation, the loop overperform the reduce and other stuff, probably because of my extra memory consumption. But rewriting everything in a loop, it speed up like 2 or 3 times the algorithm.
Yeah. It's crazy. I don't know. I mean, I'm just trying that, like try experiments. I mean, some informal experiments, not just random stuff, but yeah, it's hard.
And what was most useful, like this flame graph from Clojure Async? That was the main tool for debugging performance, yeah?
For performance, it depends, because I was trying to I used this monitor here quite a lot, because a lot of performance issues are that you're hitting the top of the heap, and then the garbage collector is constantly running, and that makes everything super slow, but it's because of garbage collection. But also it's super nice to run the async debugger to try to figure out quickly what is taking most of the time. So it's for me, I mean, I'm not super into performance, but those are the things I tend to look at. How the garbage collector is behaving, and then try to reduce the memory footprint. Maybe I'm like constantly creating some maps that are discarded like a second after or something like that, and yeah.
Okay, awesome. Thank you. That everything was very interesting. So,
Thank you.
Do you have your Clojure community in Uruguay?
We used to run a meetup here, but yeah, now I've just I know, like, I don't know, one company that uses Clojure here, and Datomic and everything, and then a couple of Clojure developers. One is the Mauricio, so that he used to work on chlorine, and he's working on Atom and all that stuff now. And he's from Brazil, but moving into Uruguay, and have met him here. And yeah. But there probably are more Clojure developers here in Uruguay, but yeah, it's a small country, just 3 million people, so I don't know.
Yeah, you should contract for a couple more companies. Introduce.
Yeah.
Okay, thank you so much. That was really awesome. So I want to try.
Okay, thank you.
All the
Thank you for
stuff you
having me.
showed.
And
Yeah.
yeah, and just for you and everybody, jump into the flow-stor channel on Clojure and Slack. If you're interested into this kind of stuff of like using the debugger or maybe improving it somehow or reporting issues on whatever. I mean, it's kind of an ongoing experiment where we try to figure out tools that can help us. And so, I mean, it's I don't think any of this tooling or FlowStorm or whatever, it's going to make us better programmers or anything. But I really think it's make the stuff more fun. And that part is really important to me because it's not about like just being like genius programmer or whatever, but also like having fun. I mean, if you need to constantly add 1,000 print lines on your code and then removing them, and that is, I mean, it's just not fun. So
okay, so thank you so much.
Okay, thank
Have
you.
a good day.
Okay,
Bye-bye.
bye.